Welcome to Intuition. This is my fourth video on Veritasium's big misconception about electricity. In my first video, I pointed out it is impossible to describe the energy transfer into the electric bulb in terms of Poynting vector. Today, I'm going to provide you some quantitative analysis in support of my explanation. Let's go. So this is a simplified diagram for the DC circuit where the electrical light bulb has been simplified as a cylindrical resistor, and so that we can calculate the electrical power based on his assumption. Here are the formula I'm going to use. E represent the electrical field strength, represented by this downward origin arrow. B represent magnetic field, represented by this blue ring. And P represent the power, which is simply the product of current and voltage. Resistance, according to definition, rho here is resistivity. This is just Ohm's law. The last one, S, is Poynting vector in his scalar form. So E multiply B divided by a constant. If we just pick out the first two and the last formula, we can obtain a formula, in this case, for the power. So because Poynting vector in the context of the electromagnetic wave represent the energy flux. So if you use a dot product of S with the area, then you get the power. So after this integration, we can obtain this power formula as E multiply B and multiply this area. If you just substitute E, the formula for the E and B, then we can get this final expression, which is exactly the definition of power. So mathematically, you can argue that the Poynting vector can be used to describe the power. So that is why in history, people had argued that we can use this fluid model to describe the energy transfer at a light bulb. Is that true? But if you want to use, if you want to treat the Poynting vector or the cross product of electric field and magnetic field as a kind of energy flux, you have to assume that the two fields must be satisfy certain condition. This is a plane wave model in which you can see that the electric field must be perpendicular to the magnetic field. Well, you can argue that this condition is satisfied. However, these two fields must be oscillating, not static. And they must oscillate at the same frequency. That is another condition. And in addition, if you want to use the Poynting vector as energy flux, you must consider that the ratio of the electrical field to the magnetic field, they have another constraint. If I use this simple wave model, plane wave model, we can derive this, let's go to this way. So if we just consider this plane wave model for the electromagnetic wave, then we can easily obtain the partial derivative. If you compare with these two partial derivative, then you can immediately obtain this constraint I'm talking about. So the ratio of the magnitude of electric field to the magnitude of the magnetic field must be equal to omega divided by k. Omega is the angular frequency and k is the wave number. So eventually you will obtain that this ratio is exactly equal to the speed of light. So these constraints you must take into account in order to use Poynting vector as energy in flux. What would be the case in our this example? If we just use the first two formula for electrical field and magnetic field, we can work out this ratio. If you can follow this simple algebra, you will obtain that the ratio in our case is 2 over rho. And this nu zero is a magnetic property of vacuum. And this r is a radius. So you can see that in our case, in our model, the ratio is not equal to speed of light. So that is why you cannot apply Poynting vector in this context, in which our magnetic, the ratio, you cannot satisfy this criterion here. All right. And another way to reject this hypothesis is that we can use this simple graphic method. So if we just simplify, if we just consider an electric bulb whose filament is arranged in this white color represented by this white line, so you can see vertical, in fact, the current direction is opposite. So if we just consider the spatial electric bulb, and you can see that we can actually decrease this distance between these two filament, two direction. So you can see that according to right-hand row, the magnetic field around this type of filament is virtually zero. Apart from, of course, between these, in the gap, you got very strong magnetic field. But magnetic fields come from the, is generated by the current anyhow. So therefore, there is this is another way to reject his hypothesis. Because after all, electric bulb, when it is on, it should acting as a radiator. We see the light is on because the light bar generates the photon. The photon is leaving. The energy flux should be toward outside instead of energy coming from outside. This is similar to the Earth, that the Earth has certain temperature, and therefore they will radiate at infrared frequency range. And although Earth also absorbs the radiation from the sun, of course, if you're interested in the climate change, and you can watch my video about this issue. So therefore, we can conclude now the hypothesis Veritasium used is invalid. It's valid, should be rejected because the ratio, the criteria we discussed here. Actually, so far we have discussed many aspects of his claims, and in my previous video, I shown that there is no internal current in the battery. Today, I demonstrate that it's impossible to use Poynting vector to describe the energy transfer into the electrical light bulb. Now, how about this other aspect? For example, he assumes that there is the two electrical lines are parallel, suggesting that that can be represented somehow by this power transmission line with extremely long distance. Actually, I noticed that since he publishes the video, and several electrical engineering actually uses the computer to calculate the time required based on that these two parallel wire can be treated as kind of the capacitors and resistors. But it must be made clear that his experimental setup is far more from the ideal transmission line. In particular, those people who actually have done some experimental measurement have been actually based on using the coax cables. It's quite a different experimental setup. In his experimental setup, it's just use some old car battery and some high school experiment switch, and presumably at the moment when the switch on, they probably have generated some sparks, so indicating there is some electromagnetic pulse spread at the speed of light. But after all, in his talk, he's actually very serious about the static condition under which everything is settled down. That whether the light can be sustained, the power can be transmitted from the battery to the electric bulb. So his experimental setup and description is quite unclear. It's not worthwhile to set up this sophisticated measurement based on very high-end electronic equipment, such as the signal generator and also the signal detector. I can tell you that these cables, these connectors are not cheap. Okay, not cheap. So it's not comparable. So it's not worthwhile. Of course, if we can, because in both cases, we can also use this equivalent resistor, equivalent circuit, so that we can use a computer model to calculate the time taken for the signal or to propagate along the coax cable. I will not go to some detail. If you're interested, I will talk about how the idea of coax cable had been developed gradually from the waveguide. Okay, so if you're interested in the waveguide, I can make some video about the microwave in waveguide. Probably it's more interesting for people to understand how the electrical wave can propagate along the two metal strips. And another thing I would like to point out is that this idea of using Poynting vector to describe the energy transfer from the source to the electrical load was made by Richard Feynman. But if you look his writing the book in detail, he has such comment here. He calls this series crazy theory. He said, so our crazy theory says that the electrons are getting their energy to generate heat because of the energy flowing into the wire from the field outside. Oh, by the way, the setup is experimental setup are irrelevant because in his case, we are not dealing with AC or electrical magnetic wave. We are dealing with primarily the DC current. So therefore, and the argument, the hypothesis is wrong in the first place because both the electrical and magnetic field are time independent after that very transient period. Okay. So in conclusion, this is Richard Feynman's conclusion. this theory is obviously nuts. Somehow energy flow from the battery to infinity and then back into the load is very strange. So I think we have to aware that this is some background. And in addition, I must point out that in order to make his explanation, in order to use this idea of the Poynting vector, one must assume that we must replace the battery by the alternating charge. In this simple case, it's just an electric dipole. This dipole must be alternating in order to generate any magnetic wave as emitter. So this is the formula for the power. Actually, this power is also can be written as in terms of the Poynting vector. You can notice that as the frequency became zero, the power becomes zero. Therefore, for the DC battery, you cannot generate any electromagnetic wave. Okay, I will stop here. And the next time, okay, in summary, so far, I have proof that it's impossible for the battery, DC battery, to generate electric wave or pulse. Second, that it is impossible for the energy transfer into the bulb. It is impossible to describe the energy transfer into the bulb in terms of Poynting vector. The question remains, so how does the electric bulb get his electrical energy? This is a big question. I'm going to discuss this question next time. Just wait for a moment. Goodbye.